Okay, so if we're finding the second derivative, I think you said that you did okay with getting that the second derivative, I should get rid of that, is x minus 1 over x minus 1 squared, or 2y minus 2 over x minus 1 squared. So if we know that that is correct, we also want to check the other ones. So for instance, and there's different representations and ways that you can find derivatives, so different things entirely can come up, but you're telling me that one is true. So in something like this, if I got this answer, I would take a point that I know is on the curve, right? So what times what equals what plus what? So 2 times 2 equals 2 plus 2. So I would take the point 2, 2, which you know is on the curve. And if we know for a fact that this one is right, then the second derivative value at 2, 2 should be 2 times 2 is 4, 4 minus 2 is 2, over 2 minus 1 is 1, 1 squared is 1 is 2. So if this also gives me 2, or this also gives me 2, it may also be correct. So when you plug in here, you get 2 over 2 minus 1 is 1, 1 cubed is 1. You do also get 2 on that one. And then when you plug in 2, 2 down here, you get 4 over 2 minus 1 is 1, 1 squared is 1, you get 4. So this one's definitely not an equivalent version of that. This could be coincidental though, so you'd find another point that is on your curve and check the second derivative there and there again. So let's take 0, 0 for instance. That also works. 0 times 0 equals 0 plus 0. If you plug in 0 to the one we know is correct, you get negative 2 over 1, which is negative 2. If you plug in 0 here, you get 2 over negative 1 cubed is negative 1. You also get negative 2. So 1 can be coincidental. 2 could be coincidental, but we're a little more certain that that's accurate. You know, it's hard to say what substitution. We could probably play around with it till we're blue in the face and figure out what did they substitute in for y is probably what they did to get it all in terms of x. We could play around with that, but this point method I think works better. If I did play around with that, let me just see here. xy equals x plus y. xy minus y equals x. If I pulled out a y, I'd get x minus 1 equals x. And y would equal x over x minus 1. So if I took that and substituted it in, I'd get 2 and then x over x minus 1 minus 2 over x minus 1. And I can kind of see where it's going to come from because you're going to have to clear a fraction. Multiply by x minus 1 on the top and on the bottom. When you multiply to the first term, it's going to cancel. When you multiply by the second, we'll have to distribute. So we're going to get 2x. Distribute your negative 2 to that, minus 2x plus 2 over x minus 1 cubed. And your 2x's, whoops, sorry. And your 2x's canceled and leaves you with 2 over x minus 1 cubed, which is also 1. So I hope that helps.